For so many games, a controller of some sort is a must. Games like GTA 5 and Assassin's Creed have one thing in common: player controller. Although very different from each other, their base controller is the same, a third-person controller. So in this video, we're gonna learn how we can make a basic third-person controller that you can add on to later to fit your game. Hey guys, it's me, Apurva. Welcome back to my channel. Now let's jump right into the video. Let's get some things clear. I'm remaking Bracky's video because it was a bit old and I'm gonna make the video better. You can also go to Asset Store and download the starter assets by Unity, which already includes the third-person controller. But if you want to know how you can make it yourself, then keep watching this video. As you can see, I already have a project open in Unity. As always, I'm using Unity URP. I have a Barbarian character imported into my project. It's free on the Asset Store. I also have an environment empty game object that holds all of my environment objects. It has a plane that I'm using as my ground and a bunch of cubes as obstacle. This video is going to be divided into 3 parts. First, we're gonna create the third-person camera. Then we'll code the movement. Then we'll make some small adjustments to make the third-person controller better. Now let's tackle the first part, which is creating the third-person camera. For that, what we're gonna use is the Unity's Cinemachine. We can obviously code the camera system, but it's much easier to use the Cinemachine because it has a lot of features already built in that we can use. So to use Cinemachine, we'll need to install it first. For that, go to Window Package Manager. Then from here, change it to Unity Registry. We'll search for Cinemachine. Here it is. You might need to download it. So just click on download and then click on install. It will start installing Cinemachine. After installing, we'll close the package manager. One quick thing here, it's always best to separate your logic from your graphics. So I'm gonna create an empty game object and call it player. I'm gonna reset its transform and drag and drop the Barbarian here. I'm also gonna rename the Barbarian to graphic. So all of our logic will sit under the player and all of our graphics will sit under graphics. Now let's create the Cinemachine camera. I already have a video on Cinemachine basics. You can watch that video to learn the basics of Cinemachine. In that video, we created a virtual camera. But for this video, we're gonna create a free look camera. So for that, right click on the hierarchy and under Cinemachine, click on free look camera. I'm gonna call it third person camera. As soon as I create the camera, it's gonna add a Cinemachine brain to our main camera. This is what actually controls the main camera's behavior. If we click on our third-person camera, there are a lot of settings here. For now, we can ignore most of them and just focus on the follow and look at. So we want our camera to look at our player. So I'm gonna drag and drop my player in the look at transform. We also want to follow our player. So I'm gonna do the same for the follow transform as well. Now if we switch back to the game view, as you can see, the camera is looking at our player, but it's a bit close. So if we go back to scene view, as you can see, the camera has 3 orbits: top, middle and bottom. These orbits control how the camera will function at different heights. So in our third person camera, if we scroll down a bit, we can see that we have the orbits option. As you can see, we have top rig, which is this one, we have middle rig, which is this one, and we have bottom rig, which is this one, and we have height and radius in our top, middle and bottom rigs. As you can see here, we need to adjust the height of the bottom rig. So I'm just gonna set it to 0 for now. Now that we have set the height of the bottom rig, let's set the radius. I want a bigger radius for my bottom rig, so I'm gonna increase it to 6. Now let's focus on the middle rig. Middle rig is the rig that the camera is always going to be sitting unless we change its height. So it's the default view that the player is going to be seeing. For me, I think I want my camera a little bit lower, so I'm gonna decrease the height in the middle rig and also increase the radius to, let's say, 10. As you can see, the camera is a lot far back right now, but I think the height is a little bit lower because it's straight. So I want my camera to be a little bit top down, but not so much. So let's increase the height to 3. As you can see, I think it looks perfect. Now let's focus on the top rig. I want the height of my top rig to 5 and let's set the radius to 8. Now let's switch back to game view and see how different rig is gonna perform. So for that, what we can use is under axis control, in y-axis we can change the value to see how our different rig is gonna look when we change the y value. So let's just change the y value. As you can see, the bottom rig looks through the ground. We don't want that, so we need to adjust the height in our bottom rig, but I don't want to set it to a higher number. So what I'm gonna do is change the height to 0.1, which is gonna just lift it up slightly so it doesn't grip through the ground. Now we can change the y value, and as you can see, this is the top rig, this is the bottom rig, and this is how it's gonna look. I think we need to increase the radius in our top rig, so I'm just going to increase it to 15. And as you can see, I think it now looks perfect for me. Now let's set it to default. Under axis control, we have the input axis for our mouse. As you can see, we have the y-axis and the x-axis. So if we just play the game, as you can see, we can rotate the camera using our mouse. We can look right and left and move up and down, and the mouse follows itself. But if you look closely, the settings are inverted. As you can see, if I go to the right, the camera goes to the left. So under x-axis, we need to uncheck the inverted, and in y-axis we need to invert it. Now as you can see, if we play, it feels right for me, but if something doesn't feel right, make sure to play with the settings and find the best setting for yourself. I'm just going to increase the sensitivity in my mouse. For that, we need to change the speed variable. So I'm going to set y-axis sensitivity to 6 and x-axis sensitivity to 500, and I think it feels a lot more snappier right now, and I kind of like this movement. But again, it's gonna depend on your game and your personal preference. One thing I'm also gonna change here is the binding mode in orbit. Currently it's set to simple follow with world up, but I'm gonna change it to world space because I don't want my camera to be affected by the player's rotation. Instead, I want my player's rotation to be affected by the camera's rotation. This all will make sense in a bit when we start adding movement to our character. Now you can also change the rigs from here. As you can see, if you just expand the settings here, you can fine-tune how you want your different rig to look like. This is pretty similar to my previous video on Cinemachine, so if you want to know what all of these different settings do, make sure you go and watch that video to find what different settings do here. But if something doesn't feel right, just make sure to play with the settings here in order to find the best camera settings for your desired look. And with that, setting up our third-person camera is done. Now let's move on to actually moving the player. Just a quick thing guys, if you're enjoying the video, make sure to like the video, and if you want to learn more about Unity, make sure to subscribe to the channel to stay updated with the latest video that I put out. There are several different ways to move your player, but the method that we're gonna use is using the character controller. So I'm just gonna select my player and add a character controller to it. And as you can see, our character controller is under the ground. So for that, we need to change the center of our character controller. For that, let's just go under center, and in the Y value, let's put 1. And as you can see, the character controller is perfectly sitting on the ground. And for your game and your character, you will adjust your character controller accordingly. But for my character and my game, I think this will do just fine. Now let's actually create the script to move the character controller. So for that, I'm going to create a folder in my assets folder and call it scripts, because I like to keep things organized. And in my scripts folder, I'm going to create a new C# script and call it third person controller and open it in Visual Studio. Since we're using the character controller to move our character, the first thing that we need is a reference to our character controller. So up here, I'm going to type private character controller. In the start function, I'm going to type controller is equal to get component and open and close these pointy brackets, and between them type character controller and open and close parentheses and then a semicolon. Because our character controller is sitting on the same object as our script, this is gonna get the character control right away. Now we need to get the inputs from our keyboard, mainly the WASD or the up and down or left and right arrow keys. So for that, in the update function, let's create a float and call it horizontal and set it equal to input.getAccessRaw because we don't want any smoothing or anything applied to our inputs. We just want the raw input, and open and close parenthesis and in parenthesis in quotation type horizontal. Make sure you type the horizontal exactly I have typed here, because if you misspell it, then it's not gonna get the horizontal axis because it's a string. In the future, I'll make a video on the new input system and show you how you can switch from the existing input system to the new input system. But for now, we're gonna use the old input system, and I'm gonna do the same for the vertical input. I'm gonna type float vertical input get axis raw and open and close parenthesis and in parenthesis in quotation type vertical. Now we have the input from our keyboard, but we need to apply the input, or we need a direction to apply the input. So I'm gonna create a vector3 and call it direction and set it equal to new vector3, open and close parenthesis and in parenthesis type horizontal for the x value, 0 for the y value because we don't want to move up and down, and vertical for the z value. And when you are using the input system to move the player, make sure to always normalize it. Otherwise, if you move diagonally, it's gonna move faster. Then we can just call the move function in our character controller. So for that, I'm gonna type character controller dot move, open and close parenthesis and in parenthesis type direction. Now we need a way to control the speed. So let's go up here and type public float speed and set it equal to something like 4f for now. And let's multiply the direction with the speed variable, and let's also multiply it time dot delta time because we want it to be frame rate independent. Now as I'm typing this, I noticed that I made a typing mistake here, misspelled the vertical here, so it's not gonna work. So let me just fix the vertical spelling. What we created here, this is gonna work just fine. If you just save the script and go back to Unity and play, it will actually move your character depending on the inputs that you give. But there is a performance issue here. As you can see, the update function runs every frame, so the controller is going to be calling move function every frame, which is not necessary. We can check if the player is pressing something, or we can check if the player is giving some input, then we can call the move function. Otherwise, we don't need any resource to call the move function. So for that, let's just type if open and close parenthesis and in parenthesis type direction dot magnitude is greater than or equal to a very small number. Let's type 0.1 here. So if we are actually giving some input, then open and close curly brackets and in there, let's just move our controller.move function there. Now the move function is only going to be called when our player wants to move, and that's something that you want. You don't want to waste unnecessary resources. Now if we go back, save the script and go back to Unity and play the game, as you can see, we can move forward and backward and left and right, but I think the speed is a little bit slower, so I'm gonna increase the speed to 7. As you can see, I think it's perfect now. But as you can see, there is a major problem here. The player is always facing the forward direction. When it's moving right or left, it's not facing that direction. So let's first tackle that. So let's open the script again, and in our if statement, what I'm going to do is create a float called target angle and set it equal to mathf.Atan2. Now what is Atan2? Atan2 is a mathematical function that returns the angle between the x-axis and the vector starting at 0 and terminating at x, y. Phew, what does that even mean? Well, here's a coordinate system. This represents our scene from above with the player in the center. The dotted line here is the direction we would like our player to point in. We can use the Atan2 function, giving it first the y and then the x coordinate of our direction to get the angle. However, this assumes that our rotation starts at 0 at the x-axis and then increases counterclockwise. But in Unity, our character will have a rotation of 0 when he's pointing forward, and from there it increases clockwise. To take this into account, we simply pass in the x first, then the y, and we have the angle we need. Atan2 and open and close parentheses and in parentheses type direction.x, direction.z, and Atan2 returns a value in radians, so we want to multiply it with mathf.rad2degree to convert it to degree. Now that we have the target rotation, we need to apply the rotation. So let's type transform.rotation is equal to quaternion.euler, open and close parenthesis, and in parenthesis type 0 for the x and target angle for the y and comma 0 for the z. Now why I'm using the y-axis in my rotation? Let's go back to Unity and select our player, and if I just rotate the player on the y-axis, which is the green color here, as you can see it rotates left and right. So this is how rotation works. So now that's done, we can just save the script and play the game. Now as you can see, our player is facing the direction that he's going, but he just kind of snaps to the direction right away, which is kind of unrealistic. So let's add some smoothing to it. So for that, let's open up our script again, and this time we're gonna need a smooth time variable. So let's create a private float called turn smooth time and set it equal to something like 0.1. Now I have made this variable a private variable, but I want the ability to change the variable in the inspector. So for that, what I can do is up here, or before starting the variable, I can just open and close square brackets, and in them I can just type serialized field. What this will does is it's gonna keep the variable private, but it's gonna show the variable in the inspector. So you should always use the private and serialized field together whenever you don't want any of the variables to be accessed from another script. This is a pretty good programming practice that you should always follow. Now that we have the smooth time, let's actually apply the smoothing. So for that, let's also create a float angle variable, and let's set it equal to mathf.smooth damp angle. Now as you can see, this takes a float current value, float target value, a reference float current velocity value, and a float smooth time. So let's just go through it one by one. So first, the float current value. So what is the current value? So the current value is going to be our transform.eulerangles.y, which is our y rotation. We want a target rotation or target angle. So for that, we have our target angle. So let's just type target angle here, and then we need a reference float current velocity. This is just a private variable that we are going to use in this script. So let's just go up here and create a private float called turn smooth velocity and type reference or ref turn smooth velocity. Lastly, what we need is the smooth time. So let's put a comma here and type turn smooth time. I know it's a bit weird syntax for a function, but this is how smooth damp angle works. Now let's just change the target angle to angle here. If we save the script and go back to Unity and play, as you can see, the character rotates realistically. Now let's tackle the second problem here, and that is moving in the direction that our camera is facing. So for that, let's again open our script, and since we're gonna move in the direction that our camera is facing, we need a reference to our camera. So for that, let's create a public transform and call it camera. And I'm gonna save the script and go back to Unity and make sure I reference the camera in the inspector, because a lot of time what happens is I code everything and I forget to reference it. So I don't want to forget it. So let's just reference the camera right now. So make sure you go and reference the main camera, not the third person camera. Remember, the third person camera is actually a virtual camera that has the settings for the main camera. It's not the main camera. So make sure you always reference the main camera. So I'm gonna reference the main camera and go back to Visual Studio. And what we need to do here is actually pretty simple. We can just add on to our target angle here. So just put a plus camera.eulerangles.y. Our character is going to be looking at the direction of our camera, but it's not gonna be moving in that direction. So in order to move in that direction, we need to also create a new vector 3 called move directions and set it equal to quaternion.euler. So again, I'm gonna set x to 0 and y to target angle and then z to 0. But as you can see, it's giving us an error, and that's because we are setting a vector 3 to a rotation, which doesn't work. So in order to convert a rotation into a vector in Unity, what we can do is multiply this with vector 3 dot forward. Now as you can see, there are no errors and we have our move direction. So lastly, what we need to do is change the direction here to our newly got move direction. Now always remember to normalize this kind of variables, because otherwise I have told you before, when you are moving diagonally you are going to be moving a lot faster. So I'm just gonna type dot normalized here, and now let's save the script and go back to Unity. And as you can see, we can move in any direction that our camera is facing. Pretty cool, right? Now our script is ready, but as you can see, we have an obvious problem here. Sometimes our camera can get stuck behind an obstacle from which we can even see our player. In order to fix that, there is actually a pretty simple solution in the Cinemachine pack. So if we select our third person camera and go down, as you can see, we can add extensions. So for that, let's add an extension called Cinemachine Collider. As you can see, this has a bunch of settings. So for now, let's just ignore most of them and let's focus on the collide against and ignore tag. So collide against is gonna be the layer that's gonna have our obstacle or the objects that we want our camera to collide with. So I already have my environment object, so let's create a new layer called ground and set our environment to that ground layer. Make sure that you also change the children, because the childrens are actually the obstacles that we want the camera to collide with. And I'm also gonna set my player to the player tag. Now let's go to the third person camera and change the collide against layer to the ground layer, and make sure to untick the default layer and ignore tag player. Now if we play the game, as you can see, if you try to block the camera with any obstacle, the camera moves to the other side. And that's because if you look at our Cinemachine Collider, under the strategy we have preserve camera height. What I want in this game is pull camera forward, so I'm just gonna select that one. And now if you play, as you can see, what this does, it pulls the camera forward, and this is actually what most video games use these days. So I'm gonna use this method, and you can also use some damping to make the transition smooth. So I'm just gonna apply some damping, let's say 0.8 and 0.8, and play the game. As you can see, right now the transition has some damping applied and it looks good. There you go guys, now you have a working third person controller in your game. You can obviously work on the controller to make it your own and add things onto it to make the controller best fit your game, and I highly encourage you to do so, because that way you're gonna learn a lot faster. And on that note, if you want to learn more about Cinemachine, I already have a video on that topic which you can check right now. And you can also watch my previous video on the first person controller to add gravity and jumping to it. So I'll link both of the videos in the description and on the end screen right now, so you can watch both of them. And I will see you in the next video. Goodbye.